delete node in a binary search tree. We are given a binary search tree and we are also given a key value. So what we have to do is we have to find the node with key value in the binary search tree and then remove it. So in this example here we are given a key equal to 3, and we are also given this binary tree over here. We'll start at a 5 and try to find this key, trying to find a node with the value equal to 3. We'll compare it with 5. We compare the key with 5. If it's less than 5, we will go leftwards, because that's how binary search trees work, are stored. So when we go leftwards, we find 3. So we have found the node that we wanted to move, and after finding it, we'll do the next step, which is removing the node. We can divide this question into two parts. First, we will find the node that we are trying to delete, and then after we have found the node, we will remove it. And we have three cases on how we can remove the node. If the node does not have a left node, that is the first case. Second case is if it does not have a right node. Third case is if it has both node. Let's see how we can solve it. If not root, if we have reached the end of the root, or in the beginning there was no root, we'll just return none. So we have to find as I said, there are two problems. First, we have to find the node that we are trying to remove. So if key is greater than root.val, meaning the node will be in the right half, because it's greater, it's a binary search tree. We will write root.write is equal to self.delete node root.write comma key. So basically what we are trying to do is we are making a recursive call, trying to find the node in the right half of the current node and also delete it, and whatever value is returned, it is stored in this. And we'll have another condition: if key is less than root.val, in that situation it is in the left half. Self.delete node root.left comma key. And else, if we have both right and left node, in that situation what we have to do, we have three cases. If there is no left node, if not root.left, we just return root.right. And if there is no root.right, we just return root.left. And there is an else condition. If there are both left and right node, what we have to do, we have to find a minimum node in the right part of the tree, and after finding the minimum node, we have to replace it with the current node, and then remove the minimum node that we took from the bottom and placed it at the current node's value. This is done to maintain the binary search tree, uh, because at the current node we can only place the element that is the minimum node, smallest node in the right half. So what we do is we find the minimum node is equal to self.min node. We'll write this function, it will find the minimum node, and we have to find it in the we have to find the smallest node in the right half of the current node. And root dot value will replace the root dot value with the minimum node value that we found, and then we will delete the minimum node at the bottom because we pushed it up. Root dot right comma min node dot val. Now we can just return the root, and it should work, but we have to write this minimum node function. This is very basic function to find a minimum node in this right half of the tree. We have passed a node, so we can just write we can just pass a node as a parameter. And as you know, in a binary tree, the left half is the smallest one, so we will keep on going left side. While node dot left will keep on going left is equal to node dot left, and when we have reached the end, we will just return the node. Let's try it out. Thank you for watching this video. Please consider subscribing to my channel.